Mother Nature has endless ways to flaunt her dazzling color. One of her most iconic are rainbows.
Whoa, beautiful.
When rainbows appear, they tend to bring extra joy to the moment.
Hey.
Perhaps not so much if you're being run over by a tornado. But most of the time, rainbows are awesome. Here's a rainbow with lightning. Here's a rainbow with a whale. Here's a rainbow with some woman eating a sprinkled donut. In this video, we showcase and explain the variety of rainbows, halos, iridescence, and other funny ways the spectra of light appear on our spectacular planet. If you take your brother's microphone and stick it in the water, notice how it appears to bend. This is due to refraction. When visible sunlight enters a raindrop, it refracts, separating into many different wavelengths. Each different wavelength appears as a different color. Some of that light is then reflected off the back of the raindrop, refracts again, and then travels to observers who aren't staring down at their phones, appearing as the Boeing spectrum. An easy way to remember the order of colors is by remembering the name Roy G. Biv. And if you're wondering what Roy's middle name is, it's Gay. The secondary rainbow appears when the light reflected twice inside the raindrop is bright enough for detection, and because this light is reflected twice, the order of the colors are reversed.
Wow, look at that rainbow.
Notice the band of darker sky between the two rainbows. This is sometimes called Alexander's dark band. In super rare conditions, a third rainbow can be seen, but it's extremely faint and you'd have the sun in your eyes. Sometimes rays bouncing around in the rain cause interference. The result can be bonus bands of color, usually underneath the primary bow. These are called supernumerary bows. All rainbows are optical illusions. They do not exist in specific spots in the sky, rather in your head. You can't see a rainbow at midday unless you're high above the horizon looking down. The closer to sunrise or sunset, the higher the rainbows arc into the sky. During these hours, sunlight increasingly messes with your head. Here, the actual location of the sun is well below the horizon, but the bending or refraction of its light as it travels the greater distances through layers of different densities in our atmosphere make the sun appear much higher. This is often referred to as the true position of the sun, but that's not entirely accurate either. It's where the sun would appear if you were just outside our atmosphere. But it took sunlight over 8 minutes to reach you there, and in that time, Earth rotates roughly 2 more degrees. So, the sun's true position relative to its appearance here is more like here. I'm going to let that sink in for a sec. Turbulent atmospheric refraction also causes the shimmer in this mirage, and the twinkle in these stars. Nice green trail on that one. And the twinkle in these stars, sorta. The farther sunlight travels through our atmosphere, the more the shorter blue and violet wavelengths are scattered, becoming less visible. When only the long wave red remains visible, a monochrome rainbow or red rainbow may appear. Anywhere you have sunlight interacting with water droplets and an observer in the right spot, you can have some kind of bow. Here's a sea spray bow. Here's one made by a whale. And I guess we'll call this one a hoser bow. The tiniest water droplets in fog tend to make a white bow or a fog bow, also called a mist bow or a ghost bow. If you look closely at the man's shadow, you might see something called a glory. The small rings of color around this airplane's shadow is called a glory. These are most often visible when the viewer is above the horizon looking down. The closer your position to the clouds, the larger the shadow. In special conditions, a hiker climbing through fog, pondering the meaning of life, may see a glory around their head and believe they're onto something. Because glories are optical phenomenon, only the observer's own shadow will have the crown of color, but their buddies will only see the glory around their own head. So far, much of the optical phenomena we've discussed is visible when looking away from the sun, but there are many fantastic atmospheric optics that appear when looking toward the sun or moon. Coronas are colorful circles of light caused by diffraction. Diffraction is when a wave changes direction as it bends around an object or passes through an opening. When visible sunlight passes by or around certain water droplets or ice crystals, the light waves bend and disperse into their spectral colors. Wider circles than corona are 22-degree halos. The even wider circles around the sun are 46-degree halos. These are caused by refraction of light through tiny hexagonal ice crystals. Halos are sometimes accompanied by a zoo of other optical phenomenon in their class, such as sundogs or parhelia, upper tangent arcs, circumzenithal arcs, and circumhorizontal arcs, to name a few.
That is wild.
When the setting sun reflects off falling ice crystals, a sun pillar may appear. City lights may produce this spectacular effect called light pillars. Sometimes clouds can have wildly vivid pastel colors resembling mother of pearl. This is called iridescence or irisation and is largely due to diffracting light wavelengths interacting with each other, causing interference. The blue orb flying around is just a lens flare refracting through the glass and interacting with my on-camera image stabilization, but will probably end up on 40 other YouTube channels as proof of aliens. The shining metallic iridescence on peacocks isn't from pigment on their feathers, but an illusion of how perceived sunlight interacts with the feathers. Similar to the way the fantastic colors diffracting off the CD appear to move, depending on the location of the observer. Watch how this wild python's colors come alive with iridescence when I move her into the sunlight. How's that for a gem? Many insects also display iridescence. In nature, iridescence turns up in all sorts of strange and beautiful places. When facing the sun, the beams of light and shadows fanning out behind the clouds or mountains are called crepuscular rays. Turning 180 degrees away from the sun, the same effects are called anti-crepuscular rays. The growing darkness on the horizon is the shadow of the Earth, also known as the twilight wedge. The fanning out effect is an illusion of the essentially parallel streaks getting closer to you, just like the way railroad tracks or a highway appear to converge to a point as they get farther away. With all the devastation and looming darkness in the world right now, wherever you are, I hope this video brought you a little light.